Welcome to this video on food toxicology, the science of what's safe to eat. This video offers a plain language tour for non-specialists on how scientists and regulators determine the safety of our food and which natural and man-made hazards we should actually pay attention to. This video is structured around 5 key questions, covering everything from what makes food different from a lab chemical to how we distinguish between allergies and intolerances, which is a common source of confusion. In part 1, we explore what makes food unique. Food is the most chemically complex thing we put in our bodies, and that complexity changes the entire rule of the game. Your dinner is essentially a chemical soup. Every natural food contains thousands of compounds, most of which have never been studied. It is important to remember that natural does not mean, quote, chemical-free. The first rule of toxicology is that the dose makes the poison. Nothing is inherently safe or toxic. Even essential nutrients like vitamin A become harmful at high doses, while harsh chemicals can be used safely in tiny amounts. Scientists split food into 2 buckets: nutrients, which keep us alive, and non-nutrients, which include everything else like natural flavor compounds, additives, and contaminants. Unprocessed does not mean simple. Ordinary foods contain hundreds of identified compounds. Because banning every food with a natural toxin is impossible, the law treats traditional foods differently than added chemicals. You cannot manufacture a tomato in a factory. Because food is variable, we rely on long experience and safety assessments focused on what happens during digestion to ensure the food we eat is safe. The gut acts as a vital gatekeeper. With an absorbing surface area as large as a studio apartment, the gut breaks down substances and acts as a filter, protecting us before things are ever absorbed into the bloodstream. In part 2, we look at how safe is decided. There is no such thing as absolute safety. Instead, the law aims for a reasonable certainty of no harm. The law doesn't demand zero risk, as that would be impractical and could lead to food shortages. Instead, the de minimis idea means that risks so small they are essentially meaningless do not need to be regulated. There are 2 different safety bars. Traditional foods are presumed safe and require clear evidence of harm to be banned, whereas added ingredients face a stricter, proactive approval process. One tool for safety is GRAS, or generally recognized as safe. This allows ingredients with a long, proven track record of safe use, like salt or vinegar, to be used without needing fresh lab studies for every application. Additives that aren't GRAS must be approved and serve a specific, justified function. There are 32 recognized categories, such as preservatives or emulsifiers, all subject to FDA testing guidelines known as the Red Book. Finally, food colors are strictly regulated. While synthetic dyes are heavily scrutinized, they often test as remarkably non-toxic because they are poorly absorbed by the gut, allowing them to pass through the body. Contaminants are an inevitable part of the food supply. Because we cannot fully eliminate them, regulators establish legal limits, known as tolerances or action levels, to keep health risks at a minimum while ensuring a stable food supply. To calculate how much of a substance is allowed, toxicologists follow a standard process. Find the highest dose causing no harm in animals, divide it by a large safety factor, often 100, to create a safe daily limit. Regulators use concern levels to match the intensity of testing to the potential risk. A chemical with a suspicious structure or high expected intake will require much more rigorous testing than a substance with a low profile. The Delaney clause is a famous, strict rule that prohibits any food additive found to cause cancer at any dose. However, it only applies to added substances, not to natural contaminants or ingredients used before 1958. Risk numbers like 1 in a million can seem alarming, but they are often put in perspective by baseline cancer rates. Most food safety alarms are resolved through careful, broad evidence review, meaning outright bans are rare. We now move to contaminants we can manage. Some chemicals cannot be fully removed, but we can set caps with safety margins. These fall into substances we add intentionally, and those that occur naturally or through processing. Pesticide residues are common in farming. The EPA sets strict tolerances for these chemicals on crops, while a 1996 law introduced an extra 10-fold safety factor to specifically protect children during their critical development years. Heavy metals like lead and mercury are elements, meaning they persist in the environment forever. While some metals are essential nutrients, others, particularly lead, are dangerous to children's brain development, making exposure reduction a top priority. Nitrites are essential for preventing botulism in cured meats, but they can produce nitrosamines. Adding vitamin C during the curing process helps block this formation, demonstrating that toxicology is often about balancing multiple safety risks. Aflatoxin, produced by certain molds on crops like corn and peanuts, is a potent natural carcinogen. It is managed by strictly testing crops and setting action levels, but always remember that visual inspection is not enough for safety. Plants produce their own pesticides, such as solanine in green potatoes. These toxins are not destroyed by cooking, so the best safety strategy is proper storage and discarding any green or sprouting parts of the potato. Trans fats were a common processing byproduct of hydrogenation used to improve shelf life. They significantly increase heart disease risk, leading to regulatory changes that push the industry to reformulate products through public pressure and disclosure. Fluoride perfectly illustrates that the dose makes the poison. It prevents tooth decay at low levels in water, but becomes toxic at high levels, showing how the exact same substance can lead to opposite health outcomes. For a rare few substances, no amount is considered safe. These potent toxins are strictly regulated to ensure no detectable trace remains in our food supply. From seafood to bacterial toxins, these zero-tolerance substances are rare but potent. They represent the extreme end of food toxicology, reminding us that ordinary food safety is usually about managing common, everyday risks. Seafood poisons break the usual rules of safety, making them uniquely dangerous. Unlike many other risks, these toxins often come from the algae the fish consumed, meaning a specific species might be perfectly safe in one bay, but toxic in another. These toxins are also notoriously heat-stable and tasteless, meaning cooking does not make them safe. While most have a zero-tolerance policy, saxitoxin, which is found in red-tide shellfish, is a notable exception with a specific regulatory limit. Two notorious seafood toxins are ciguatera and the tetrodotoxin found in pufferfish. Ciguatera hides in hundreds of warm-water reef fish, while pufferfish is a licensed delicacy that is only safe if experts remove the toxic organs. For toxins like these, there are no antidotes. Supportive care is the only treatment, and because even a tiny amount can be lethal, careful regulation and expert preparation are the only ways to prevent poisoning. Some shellfish toxins target the nervous system directly. Amnesic poisoning, caused by domoic acid, can lead to permanent memory loss. Neurotoxic poisoning, linked to Florida's red tide, causes irritation and is primarily a threat when aerosolized. When dealing with bacterial poisons, killing the germ isn't always enough. Some bacteria leave behind heat-stable toxins that survive even after the bacteria themselves have been destroyed by cooking. These toxins typically build up when food is held in the danger zone for too long. Often, these instances result in a brief, unreported stomach illness that people just call a 24-hour bug, even though it's a foodborne toxin. Botulism is perhaps the deadliest example. A mere nanogram of this toxin can be fatal. It thrives in low-acid, oxygen-free environments, making improper home canning or garlic stored in oil significant risks. Protecting against these toxins relies on proper canning and refrigeration. Boiling food for several minutes can destroy the botulinum toxin itself, providing a final line of defense against these potent, preformed poisons. In the kitchen, high heat can actually create new toxins. Grilling or charring muscle meat produces heterocyclic amines, which are DNA-damaging compounds. These form right in the smoke and char of your food. You can reduce your exposure to these compounds by lowering the heat, flipping meat frequently, and trimming away burnt parts. Even using marinades can help mitigate their formation during cooking. Starchy foods also present a risk when browned at high temperatures. This is where acrylamide forms, a compound labeled as probably carcinogenic. Aiming for a golden color rather than dark brown is a simple, effective way to reduce intake. Distinguishing between allergies, intolerances, and poisoning is vital. A true allergy is immune-driven and can be triggered by trace amounts, while intolerances are usually genetic, and poisoning is a direct, dose-based chemical effect. Most serious allergic reactions trace back to a small handful of foods, such as milk, eggs, peanuts, and soy. This is exactly why clear, mandatory allergen labeling is so critical for public safety. Ultimately, the biggest real-world food risk remains standard microbial contamination. By keeping food at safe temperatures and practicing good kitchen hygiene, you address the hazard that actually causes most foodborne illnesses.